Dr. Michael Fuller 1958年畢業於英國劍橋大學嘅自然科學系，喺1961年得到劍橋大學嘅地球測量同地球物理學博士學位，並由1965年開始喺美國匹茲堡大學擔任副教授。到咗1994年，開始任職美國加州聖巴巴拉大學地質科學系主任同教授，並同時由1994年開始擔任美國夏威夷大學地球物理學及行星學研究所嘅高級研究員。當佢喺夏威夷大島上嘅基拉維厄火山 Mount Kilauea 研究活火山嘅熔岩活動時，意外咁發現地球嘅地磁喺過去曾出現多次地磁轉向現象，即係地球嘅南北極出現180度嘅倒置，而每次出現都係喺短時間內突然發生嘅。因為當火山湧出嘅熔岩流入海面時，海水會使熔岩立即冷卻，並記錄咗當時嘅地磁強度同磁場方向。
On the big island of Hawaii, some of the heat that drives the Earth's dynamo finds its way to the surface.
All right, now I'm in.
For several years now, Mount Kilauea has been continuously erupting.
Well done.
Scientists from the U.S. Geological Survey need to sample the lava to keep an eye on the volcano.
It solidifies pretty fast, as you can see.
But geophysicist Mike Fuller is interested in the lava for another reason: what it tells him about the Earth's magnetic field. It all begins when the lava hits the sea.
You can see the lavas having moved down from the volcano up here, sometimes in tubes, mostly in tubes. Now we're beginning to see it come out and go into the water and form the very newest bit of the island chain of Hawaii. As this lava hits the seawater, of course, it really chills very, very fast. And a very wonderful thing happens. They actually trap in, they record the Earth's magnetic field.
As they solidify and cool, these volcanic rocks are preserving a record of today's magnetic field. But the volcanoes of Hawaii have been erupting on and off for millions of years, building up the islands. Every layer of lava contains a record of the magnetic field at the time of that eruption. So the Hawaiian archipelago is a hidden chronicle of the Earth's magnetism stretching back 5.5 million years. That record shows there have been many fluctuations in the field's strength, but it contains something else of great significance. When lava cools, as with pottery, magnetic regions form within it. Acting like microscopic compass needles, they record not only how strong the field is, but also in what direction it is pointing. Today, the Earth's magnetic field runs from south to north, which is why compass needles point toward the North Pole, and recent lava flows record a field pointing north. But 50 years ago, when scientists measured the magnetism trapped in older lava samples, they made a startling discovery. The microscopic magnets within the lava were all pointing south.
When we go back about 700,000 years, we find an incredible phenomenon. Suddenly, the rocks are magnetized backwards. Instead of them being magnetized to the north, like today's field, they're magnetized to the south.
It seemed that prior to 780,000 years ago, Hawaiian lava must have cooled within a global magnetic field that was running to the south and away from the north, exactly the reverse of today. The bizarre implication was that at some point, the entire global magnetic field had done a sudden 180-degree flip, completely reversing direction.
was hard for people to accept. They did not like the idea that the field reversed. It took about 50 years to convince people of this. But eventually, that was established, and really by work on this island, because if you keep on going down, you would find that after about another couple of 100,000 years, then it changes again, and you see this sequence going on.
And as they examined samples from older and older lava, scientists found more and more reversals. On average, one every 200,000 years.
And so by the time people had done that, it was pretty obvious that the field did indeed reverse.
But if the field has reversed so often in the past, it must surely do so again in the future.
That the Earth's magnetic field reverses is an extraordinary phenomenon. But this reversal process is quite common. The last reversal was, 780,000 years ago. Before that, there was one about 200,000. Before that, again, actually less than 200. So in a sense, we are a bit overdue for a reversal.
So is this why the field is growing weaker today? Could it be getting ready to flip?